In this video, you're going to be taking notes about enzymes and biochemical reactions on your 3.4 study guide. So you want to make sure you have your 3.4 study guide out and you are taking notes and answering the questions as we go along. You might need to pause the video every once in a while to catch up and then move on. So the first thing we're going to talk about is the idea of chemical reactions. A chemical reaction is any time we take one substance and create a completely new substance. So a process that changes a chemical substance into another. For example, we could take magnesium, add in some oxygen, and it's going to create or yield magnesium oxide. So we have created an entirely new substance that is different from the substances that we've started with. That is a chemical reaction. Now what we just wrote here, this entire thing is called a chemical equation. Now there's some certain parts of chemical equations that we should be able to talk about. So let's rewrite this one. We're going to write it so that it's balanced. So let's take a look at it. The stuff that we start with, the magnesium and the oxygen, it's on the left-hand side of the equation. This stuff is called the reactants. The stuff that we create, or the stuff that we end with, anything and everything on the right side of the equation are called products. Reactants and products. Some other things we have, this large 2 is called a coefficient. This small 2 is called a subscript. Okay. Something else we can do with chemical reactions or chemical equations, is count how many elements we have on each side of our equation. So on a reactant side, we have magnesium and oxygen. This large 2 gets distributed into the magnesium. So I have 2 magnesiums. The subscript indicates I have 2 oxygens. On the product side, I could do the same idea. Magnesium and oxygen. This 2, once again, gets distributed to each, the magnesium and oxygen. And remember, if there's no number, we assume it's a 1. So this is like 2 times 1, so I have 2 magnesiums. 2 times 1 oxygen, I have 2 oxygens. So what we've just shown here is the idea that matter is not created or destroyed, or whatever mass we start with on the reactant side is equal to the mass that we end with on the product side. This is following the law of conservation of mass. Which states that matter cannot be created or destroyed. And we know it is not being created or destroyed because I start with 2 magnesiums, I end with 2, I start with 2 oxygens, and I end with 2. At this point, you should be able to answer numbers 1 through 6 on your study guide. So if you need to stop the video, you should do that and answer them now. Chemical reactions can be lumped into 2 types. You can have an exothermic reaction, or you can have an endothermic reaction. Now, we know that this subscript exo means out, and thermic means heat. So this reaction releases energy many times in the form of heat. Endo means in, thermic means heat. So this chemical reaction is going to absorb energy many times in the form of heat. So let's talk about some examples. So a good example for an exothermic reaction is if I took some methane and I lit it on fire. So the burning of methane. It releases energy in the form of heat and light. For our endothermic reaction, a good example is a cold pack. These are like those crack packs that you might use if you get hurt when you're playing sports. Here they are absorbing energy, so the temperature actually goes down. Now, one thing that a lot of chemical reactions need is something called activation energy. Activation energy is the energy needed for a chemical reaction to start. A lot of times we call it the minimum energy for a chemical reaction to start. Most reactions actually won't begin naturally on their own without some type of energy. So take, for example, a match. A match has all the ingredients it needs to start on fire on the very tip of it, on the very edge of it. However, it won't start unless you strike it. When you strike it, that is the activation energy in the form of friction. At this point, you should be able to answer number 7 through 11 on your study guide. Now, what if chemical reactions are taking place inside of an organism through some type of biological means? When chemical reactions take place inside of an organism, this is called metabolism. So again, metabolism is a biochemical reaction. It takes place within organisms. There's two types of metabolism or biochemical reactions. The first one is a catabolic reaction. A catabolic reaction is another way of saying an exothermic reaction. It's just that it's happening inside of an organism. These are exothermic, and they break down molecules into smaller parts. So let's give an example. Let's say I start with a large molecule like a sugar molecule, C6H12O6. Okay? We can break that down to create CO2 plus H2O plus ATP in the form of energy. So we went from a large molecule to some smaller molecules. We released energy in the form of ATP in this situation. So this is exothermic, this is catabolic, it's making large molecules into smaller molecules. Now, anabolic reactions are the exact opposite. These reactions happen within organisms, and they take smaller segments, smaller molecules, and they use energy, again, in the form of ATP, and they create larger molecules like our sugar. This is an endothermic reaction. We're taking smaller molecules and we're creating a larger molecule. That's anabolic. So again, metabolism are specific chemical reactions that take place within an organism. There's two types, catabolic and anabolic. You should now be able to answer numbers 12 through 16 on your study guide. Most chemical reactions that take place need help, and sometimes they get help from an outside source. called a catalyst. A catalyst is a substance that reduces activation energy, which means the reaction can go faster. Now, if I'm talking about a specific type of catalyst that's inside of an organism, the special type of catalyst that's inside of an organism is called an enzyme. Enzymes help reduce the amount of activation energy needed, which makes reactions go much faster. Now, how does this relate to reaction rates? Without enzymes, most chemical reactions won't take place. They've reduced the amount of activation energy enough so that a biochemical reaction can take place. Enzymes are made of the macromolecule proteins, which, as we just said, is called a catalyst. So how do catalysts work? Well, let's kind of go over it. Or I should say, how do enzymes work? Enzymes have unique structures. The proteins each have a unique structure. So for example, maybe we'll have an enzyme that looks like this. It looks like a little E. On our enzyme, we have an area called the activation site. And that's area right here. This site is unique for enzymes. Only certain substances can bind to it, and when those certain substances do, the enzymes help speed up reactions. So let's take a look at one of these reacting. So here we have our enzyme. Okay, we're going to have two substances coming together. One that looks like that. One that looks like that. Substance A, substance B. These are called substrates. So you'll notice that the substrates fit into the enzymes very specifically. Sometimes people call it like a lock and key. So these are our keys, this is our lock. So as these two come together, the enzyme forces them to collide with each other. Here's our A, here's our B. It forces them to react. And once they react, you can have something along the lines of substance AB. Now, what would happen if conditions change? For example, if our enzyme looked like that. If our enzyme changed its shape, the substrates would no longer fit, and the activation energy would stay high, and the chemical reaction might not take place at all, or it would go really slow. So what's important here to understand is that inside the body, if conditions change too much, conditions such as temperature, ionic conditions, the pH of the surroundings, that could affect how the enzyme works. Other things that affect how enzymes work and overall chemical reactions include enzyme concentration, substrate concentration, meaning how many substrates I actually have available for bonding, and if we have something called an inhibitor or activator attacking our enzymes. So at this point, you should be able to answer questions 17 through 21 on your study guide. Again, you want to make sure you go back, you have all your answers correct and complete before you get to class.